Hello and hi to our respected lecturer and to all my friends. My name is Muhammad Zuhilmi Imam bin Zakaria, and today I will be presenting my project report. My presentation is titled Solving Problems Efficiently, the Look for Pattern Heuristic, and we will be looking at an analysis of a cylindrical tank problem. Let's begin. First, let's understand what heuristics are. In mathematics, heuristics are basically strategies that help students solve difficult problems more effectively. Think of them as thinking tools. They get us to think logically and to explore different methods when we face a complex question. According to a sources from Coursera Lab, these math heuristics are useful techniques that allow us to break down word problem into smaller parts and find suitable solution. This means that instead of just depending on memorizing formulas, heuristics help us develop our thinking process. For today's presentation, the main focus will be on one specific heuristic called look for pattern. This strategy encourages us to find repeated relationships or sequences that can help solve the problem. So, why did I choose this particular heuristic? The reason is that look for pattern is a very powerful method. It encourages students like us to observe, analyze, and make connection between different mathematical ideas. By identifying these regularities in numbers, shapes, or relationships, we can start to predict outcome and build our logical reasoning skills to solve problems. A source I refer to, Seashell 2025, mentions that this heuristic helps students recognize structure and repetition, which are very important for understanding mathematical concepts. Basically, it trains us to think critically and discover general rules based on what we can see from the examples. It's not just about memorizing steps, it's about understanding why a pattern works, which builds a much stronger foundation for problem solving. Okay, now let's look at the problem we need to solve. Imagine a club has 60 liters of paint. This amount is exactly enough to cover the curved surface area of their original cylindrical tank. Let's call this original area A1. Now they propose a new tank design. For this new tank, the radius is double compared to the original one. So we can say R2 equal to R1. However, a very important condition is that the volume of the new tank must be the same as the original. So V2 equal V1. The main goal is to figure out if the same 60 liters of paint is enough to cover the curved surface area of the new tank. So, how do we solve this? My plan is to simplify the problem and look for a pattern heuristic. Instead of trying to calculate everything with specific numbers right away, I will use variable to represent the dimension. This will help me find a general relationship between the original area A1 and the new area A2. Here are the steps I will follow. First, I will express the constant volume relationships using variable. Second, I will use this to find a pattern that connect the old height H1 to the new height H2. Third, I will substitute this pattern into the curved surface area formula to find the relationships between A1 and A2. And finally, I will use this final pattern to make a conclusion about the paint. Alright, let's carry out the plan. First, we need to find the pattern for the height. The problem states that the volume is constant, which means V1 equal V2. The formula for a cylinder's volume is V equal pi r square h. So we can write the equation pi r square 1 h1 equal pi r square 2 h2. We are given that the new radius is double the original. So R2 equal to R1. Let's substitute this into our equation. It becomes pi r square 1 h1 equal pi times with 2r1 square h2. When we expand the bracket, we will get pi r square 1 h1 equal pi times by 4r square 1 times by h2. Now, you can see that we have common terms on both sides. We can cancel out pi and r square 1 from both sides. This leaves us with a very simple relationship, which is h1 equal 4h2, or if we rearrange it, we find that the new height h2 is 1/4 of the original height h1. So here is our first pattern. To keep the volume the same, if you double the radius, you must reduce the height to 1/4 of its original size. Now that we know the relationships for the height, let's find the pattern for the curved surface area. The formula for the curved surface area is A equal to pi RH. For our new tank, the area A2 is equal to 2 pi R2 H2. We already found the pattern for R2 and H2. We know R2 equal to R1 and H2 is 1 over 4 H1. Let's substitute this into the area formula. A2 equal pi times with 2R1 times with 1 over 4 H1. Now we just need to simplify this expression. Let's rearrange the numbers. A2 equal 2 times 1 over 4 times 2 pi R1 H1. If you look closely, the term in the second bracket 2 pi R1 H1 is actually the formula for the area of the original tank, A1, and 2 times 1 over 4 is just half. So the final relationship is A2 is half A1. This is our final pattern. So what does this pattern A2 equal half A1 tell us? It clearly shows that the new tank's curved surface area is exactly half of the original tank's area. We know that the original 60 liters of paint were exactly enough for the original area A1. This means for the new area A2, they will only need half of that paint. So the paint need for the new tank is half times by 60 liters, which equal 30 liters. The club has 60 liters of paint available. Since they only need 30 liters, the paint is definitely sufficient and the answer the main question of the problem. A good problem solver always look back to check their work. Is our solution logical? I believe is it. Our method directly answered the question of whether the paint is sufficient, and we did it without needing to calculate the exact measurement. The logic is strong. When you double a cylinder's radius, its base area increased by 4 times because of the r square term. So, to keep the volume constant, the height must decrease significantly by a factor of 4. This large drop in height more than makes up for the bigger radius when we calculate the curved surface area, resulting in smaller overall area. Our final result, A2 equal half A1, confirm this relationship perfectly. This bar chart from my report helps to visualize the changes we calculated. The blue bars represent the original tank and the orange bars represent the new tank. Let's assume the original values are our baseline. As you can see for radius, the orange bar is double the blue one. It goes from 1 relative unit to 2. But for height, look at the big difference. The orange bar is only 1/4 of the blue one, going to from 1 unit down to 1. The final result is shown in the curved surface area. The new tank's area is exactly half of the original tank's area. This visual makes the relationship we found very clear. So, from this analysis, we can see a key geometric principle at work. When a cylinder's radius is double, but the volume is kept constant. First, the base area increased by a factor of 4 because the area formula depends on the radius square. To keep the volume the same, the height must then decrease by a corresponding factor of 4. Finally, this huge reduction in height has a bigger effect than the increase in radius when we calculate the curve surface area, causing the final paintable area to be half. What does this mean in practical terms? It shows that the student's idea to double the radius is a great example of creative and critical thinking. The new design is not just different, it's more efficient in its use of the special paint. It demonstrates how a simple adjustment to one parameter, the radius, can have a significant and positive impact on the amount of material needed. The main finding is that it only requires 30 liters of paint compared to the original 60 liters. To conclude, this entire exercise shows that using the look for patterns heuristic is very effective for guiding logical reasoning and problem solving. By focusing on recognizing regularities and relationships, we can make accurate prediction and draw meaningful conclusions without getting stuck on complicated numbers. This approach does not just give us the answer, it strengthens our mathematical understanding and encourages us to think in a more creative, analytical, and reflective way when we are faced with real-life problems. Here are the references I used from my report to do this presentation slide. And that's all from me. Thank you.